Okay, we're going to continue with chapter 4, making decisions. We started by going over the relational operators, and we mentioned that these operators are going to be executed in the A&L unit. The result of the expression of evaluating the expression will always be either true or false. So we're going to have a Boolean value that is going to be the result. It will always be 1 or 0. Right? It's just one bit that is going to result from the evaluation of the expression. And we started with the first format of the if statement, which is what we call the simple if. We start with the keyword if, then we have a condition in parentheses, which is what is going to be evaluated, right, in the A&L. And then within the brackets, we're going to have all the statements that will be executed if the result is true. Only if the result is true. If the result is false, then the block, the complete block, is going to be skipped. Then we continue with the second type, which is the if-else, and we also apply this one, right, to the program. So in the if-else, instead of having just one block, we're going to have 2 blocks. One block is going to be executed if the result of the expression is true, and the second block is going to be executed if the result of the expression is false. Never both. It's one or the other. How is the computer going to choose which one? Well, the true block is going to be the first one, the one that is between the if and the else, which is going to be this part right here. This is the true block. And this is going to be the false block. So if I have x greater than 5, and this is true, the result is true, this part is going to be executed. And this part will be skipped. So when it gets to the else, it's going to just jump and continue with the next instruction underneath the curly brace, which is going to be the one that is enclosing the block. So in the if statements, the curly braces, they are very, very important because they are going to indicate this is what we have inside the true block and this is what we have inside the false block. If by mistake I misplace this curly braces, then remember the computer is just going to follow our instructions. So it's going to give us the wrong results. So the next type of format is the if-else if. The if-else if is going to help us make a second question inside the when we evaluate and if it's true or if it's false. In this case, it's going to be always when it's false. So if I have, like, I'm going to be checking if it's the major is CIS or CWD or COSC. 3 different cases, right? So I'm going to say if the major is CISC, do this. If not, then ask if the major is CWD. If it is, do something. If it's not, check again if the major is COSC. So every time that the condition is false, I'm checking for another case. Another example will be if I have like a menu and I have the following option. Number 1, you're going to be adding a class. Number 2, you're going to be removing a class. Number 3, you're going to print the statement of charges. And number 4, you're going to exit. I'm going to be asking if it's number 1, I'm going to have in that block all the instructions are going to be used so that you can add a class. But if the result of this is false, is not true, okay, this condition was not met, then I have to ask if it's a 2. So in the else part, I have an if, I have another question. Then if it's not 2, then I'm going to jump to the next one. So another else is going to be needed so that I can have, okay, these are the instructions so that you can print the statement of charges. And then we can have another one, right? If it's 4, exit. And if it's not 1, 2, 3, or 4, we can have a statement saying, hey, wrong selection. You need to choose a number between 1 and 4. Because the user, the one that was working with the computer, made a mistake, right? We only have those 4 options. Or number 1, or number 2, or number 3, or number 4. But maybe by mistake, they type the wrong number. Nothing between 1 and 4. So we have to let them know. So this new format is going to help us check for more than one case. More than one case. So we have the change of if statements, the test in order until one is found to be true. And here's another example. If the condition 1 is true, we're going to do this block. This is going to be our true block. If it's false, it's going to jump, right, this section, and it's going to go the way to the else. Now the else has another if. So we know that we're going to be asking for another condition. If it's 1, if it's 2, if this is the case of our menu. If it's true, again, we're going to be doing this section right here. This is going to be the true part for this second condition. But if it's false, again, we're going to be jumping to the next one. Each else is going to be with an if. It's a combination of else and if. At the end, we can have what is called a trailing else. The trailing else is going to give us the option like I indicated right here. If it's not 1 and it's not 2 and it's not 3 and it's not 4, then else, we know that it's not 1, 2, 3, and 4, then there was a mistake. So the else, that trailing else, is going to help us test that the values are correct. They are within the range. Here's an example. They're checking for age. So the age was going to be inputted by the user. So we have age here. We have a value. Let's suppose that the value is going to be 25 this time. So we have our first if. We're going to add the curly braces here. And we're going to check, is the age greater than or equal to 21? If this is true, this cout is going to be executed. So we're going to display adult on our screen. Let's suppose that it was not 25, that it was 15 this time. So we go in and we check again. Is age greater than or equal to 21? No. So this section is going to be skipped and the execution moves to the next line, which is the else. In the else, we have another question. So we're asking, is the age greater than or equal to 13? And the answer is yes, it's 15. So if this is true, then this section is going to be executed and we're going to be displaying teen on the screen. Let's suppose that the value was 5 only. Again, we come in and we ask, is the age greater than or equal to 21? No. So we jump. And then we ask again, is the age greater than or equal to 13? No. So we jump and we go to the next cell. Is the age greater than or equal to 2? It is. So child is going to be displayed on the screen. Now let's suppose that the value was 1. So we start again and we get 1 in age, and we ask, is age, which is 1, greater than or equal to 21? No, so we jump to the else. Then we ask again, is the age greater than or equal to 13? No, so we jump. And now in this one, is the age greater than or equal to 2? No, it's a 1, so we go all the way to the else. So this else has no if. So we know that is the trailing, is the last one on the list. So this is going to be executed. So if it's not an adult, it's not a teen, it's not a child, it has to be a baby. So that is going to be displayed here on the screen. So we call this a trailing else. That's what we're going to do. We're going to change our program that we did on Tuesday. Yes? In Tuesday, we covered 2. The simple if, which is just, it has 1 true block, right? Then we cover also the if else, which has the true and the false blocks. Now we're adding another variation, which is going to help us. If it's a false result, we are going to be asking again. And that's exactly what we did on Tuesday. But we nested our if, right? We put it inside. We're going to take it out, and we're going to change our program and put it with the if else if. But here's the menu-driven program. I explained to you that this is what we have, right? This is a menu-driven program, which is the natural place where we're going to be doing our ifs. And they call it a menu because we have a list of choices. And we call a menu-driven program because this is a program that the execution is going to be controlled with if, else, if. Okay, that's where we're going to see that most of the if, else, if are going to be needed. Now, one more thing that we need to always be aware of is the user, the one that is working with our program, is going to make a mistake. So whenever we ask for values, for input values, we always need to test. We always need to test. If we're asking enter a tax rate, we want to make sure that they don't put a 0. We want to make sure that they don't put a negative value. We want to make sure that it doesn't go over what is normal for that. If we ask enter your age and they type a 99, we cannot work with that value, right? Not even save it in our database, because that's an incorrect age probably, because this is a student or it's an employee. Or 999, just a number that we know that it will never be. So what we need is to always be checking our input data. So our ifs are going to be one way to do it. Okay, in chapter 5 we're going to be learning another method, but for right now this is what we have. On Tuesday we did a nested if, and that is in section 4.6. So our nested ifs, okay, that means we have an if within another if. Again, I'm going to ask you to use your curly braces. So if I have just one here, we want to use our curly braces so that we can get used to the blocks, the true block and the false block. Questions? Okay, we're going to go back to our program. And we're going to change it. We're going to use the if, else, if. as soon as it finishes loading. We're just going to open it, the one that we did on Tuesday, because we want to change that one. Okay, let's see if it's done. When they reinstalled all the Visual Studio software, they did something to my computer. Okay, so this is the program that we did. We were comparing two numbers. We were asking the user to enter the first number. Then we asked the user to enter a second number. Please enter your first number. And we have num1, a variable, where we're going to be receiving the value. Then please enter your second number, and we have num2, where we're receiving the second number. And then we have, okay, compare them. If number 1 is less than number 2, then display the following. The smaller number is num1. And the larger number is num2. Else, we have here a false part, right? If number 1 is equal to number 2, we have here another option. We nested the if inside. How can we change this so that it can give us the same thing? In this program, we're not only deciding which one is smaller and larger, but we're also indicating if the numbers are the same. So how can I change this to and apply the if, else, if? Okay. We're going to make this an if else, right? I'm going to indent. Okay. So if this is not true, we're going to jump to this else if, and we're going to be asking if they are equal. If they are equal, what do I want to say? The numbers are equal, right? I'm going to indent. Then if num1 is less than num2, we're going to say the smaller number is num1, the larger number is num2. That's perfect. But if this is not true, we're going to jump and we're going to ask if num1 is equal to num2. And if that is true, we're going to say the numbers are equal. What if it's not? Okay, we go to the else, we're going to have a trailing else. We don't ask again, right? And when we don't ask again, we call it a trailing else. It's like the closing else. So if it's not, num1 is not less than num2 and they are not equal, then the other option is num1 is going to be greater than num2. There's no other option. Whatever number we type is going to be one of those routes, one of those solutions. Either number 1 is greater than number 2, or number 1 is smaller than number 2, or they are equal. Run it. Can we change the order? Yes, definitely. And run it and test it with the 3 options and see if you get the correct results. No, this is not nested. We had it nested. This is using the if, else, if with the trailing else. That's correct. No, when it's nested is when I have an if, like within another if. It worked, Kristen? Okay. Can we change here the order of the questions? Yes. I can, instead of asking for greater than, right here, or for equal to, excuse me, I can ask for greater than. So this is not going to be my case. This is the one that I'm going to be using. So I'm asking first, if num1 is less than num2, display this message. The smaller number is num1, the larger number is num2. Else, it's not this case. So I ask, okay, is num2 greater than num1? So if it's not less, I'm asking if it's greater than. If it is, then the small number is num2 and the larger number is num1. But if num1 is not less than num2 and num1 is not greater than num2, then I know that they are equal. So the trailing else is going to have the numbers are equal, which is what you were asking. Can we change the order? Yes, as long as we always ask the 3. Questions on the if? When we are checking for relational operators, many times we need to use with the relational operators some logical operators, and we have 3. We have the and, the or, and the not. If I want to send letters of recognition to the CIS students that have a 3.5 GPA or above, then I can use an if, else, if statement, or a nested if, or I can use one of these logical operators. The AND is going to be indicated with this operator, 2 ampersand. Excuse me. The OR operator is going to be indicated with 2 vertical lines. And the NOT operator is going to be indicated with the exclamation mark. The AND is the new relational expression is true if both expressions are true. So I'm going to have 2 expressions in parentheses, and I'm going to have AND. Both expressions must be true in order for the whole expression to be considered true. Remember, it's only one answer, right? One Boolean answer that is going to be either true or false. So both are going to be combined. And in order for us to get one true answer, both of the conditions, or as many conditions as we have, must be true. With the OR, okay, the new relational expression is true if either expression is true. So we have one to the right side and another one to the left side. So the result of that testing is going to be true if one of them, the right side expression is true or the left-hand side expression is true, then it's going to result in a true value. The NOT is going to reverse. Is going to reverse the answer. So if I have its major equal to COSC, and the answer is yes, it's true, but I have the exclamation mark, the result of that evaluation is going to be false. It's just going to reverse it. So this is the way that we're going to be coding it. We're going to be using an if statement, okay, and that will be before the keyword, and then in parentheses both conditions that are going to be surrounding the operators, okay, the and the OR. So like in this case we have is X is going to have a 12, Y is going to have a 5, and C is going to have a -4. So we ask, is X greater than Y? The answer for this one is true, right? So we have an answer right here. Then we have, is Y greater than Z? Y is a 5, Z is a -4. This is true. I have an AND operator here. So in the AND, both expressions are true, and then this is going to give me a true. So this is going to be true. We have another if. X is greater than Y. X is greater than Y, yes. So this is the true answer. And Z is greater than Y. -4 is not greater than 5, right? So this is false. I need for both of them to be true in order to receive a true answer. So in this case, I have a true and a false. So the answer cannot be true. It's going to be false. With the OR, I have an if. With the OR, either one can be true and everything is going to be true. So I have, is X less than or equal to Z? X less than or equal to Z? No, this is false right here. And Y, is it equal to Z? Y is a 5. Is it equal to a -4? No, this is false. Both of them are false. And what we have here is that I need at least one of them so that everything can be true. So this is going to be false. The next one, if X is less than or equal to Z, X is a 12, Z is a -4. X is not less than a -4. So this is going to be false. Then the next one is Y not equal to Z. Not equal to Z. Y is not equal to Z. Is that true or false? This is true. So if one of them is true, everything is going to be true. And then we have the last one. the not, it's outside. So in this case, it's going to be if not, which is reverse the order, right? X greater than or equal to Z. X is greater than or equal to Z. This is true. But because we're changing this, it reverses, and now it's going to be false. Okay? When we have a combination, we can combine and, ors, and nots, then we have a precedence, just like we have a hierarchy of operators when we're working with arithmetic operators. Parentheses is going to be performed first, then multiplication and division, and after that, addition and subtraction. The same thing will be here. So the CPU is going to evaluate first the nots, then the ands, and the last one is going to be the or. So in this case, this part is going to be evaluated first and then the or. So we have it's 5 greater than 6. No, right? This is false. Is 7 greater than 8? This is false. So everything here is going to be false. And then we have the or. Is 2 less than 3? Yes. So we have a T, a true, and a false. Because we have the or, then this is going to be true. The whole thing is going to be true. Because that's the way that the computer is going to do it. When we have a combination, and that can be done, a combination of arithmetic operators, relational operators, which are, remember, the less than, greater than, and so on, and the logical operators, which is the and, the ors, and the not. This is the way that the computer is going to do it. First, arithmetic operators, then relational operators, and the last thing is going to be logical operators. Okay, we're going to do a program. So let's apply all this that we're discussing. We're asked to create a program that will input the user's name and final grade. And then this program is going to display the user's name and the letter grade. So they are going to give us the final grade in number, and we're going to be giving them the letter grade. If the number is between 100 and a 90, we're going to give them an A. If the number is between an 89 and an 80, we're going to give them a B. If the number is between a 79 and a 70, we're going to give them a C. And if the number is between a 69 and a 60, we're going to give him a D, and everything else is going to be an F. So these are the rules. I'm trying to get my shortcut menu. There we go. Okay, so we're going to ask the user, enter your name. Enter your final grade. And then we're going to display the information. So and so, because we don't know the name, right? You have A and then whatever letter that is for this class or something like that. Okay? So we're ready to start CityCut. What do I need to do first? Okay. Our preprocessors directive, what do I need? Remember all of them. Always have the list ready. IOStream, IOManip, CMath, and string. That's it? String. Why string? I need it so that I can receive a string value for the name. If it's going to be a string constant within the program, then I don't need it, but I'm going to be receiving from the keyboard to the buffer, from the buffer to main memory, so I do need it. So I need string as well. So I need this too. Okay, after I do my preprocessors, I'm ready to start my program, right? The int main. And what is the first thing that we always use or declare? the variables. What variables do I need? I need a name. That is going to be string. And a grade. Integer, okay. Okay, we can decide. We can write the instruction only whole numbers. If they input an 89.5, it's going to drop the 0.5 because it's going to go to an INT. But you have to make that decision. You're the programmer. Okay. Many of the times it will be by yourself. Other times you will need to check with your supervisor or whoever is requesting the program. That's one of the questions that we need to ask. The letter grade, okay. That is going to be a character. Okay, I think that's it, right? Now we can start. I declared my variables, so I'm ready to start my first step, which is always the input, right? So do I need some input from the user? Yes, I need a name and I need a letter, final grade number. So I'm going to input name. So I'm going to put here prompt message and input name. And then again prompt message and input final grade. I know that when I say prompt, I'm referring to this, right? Enter your name, the instructions for the user. With the second prompt, I enter your final grade. That is my prompt message. And one of them is going to be so that I can give the instructions so that the user can give us a name, and the other one is going to be so that I can get a final grade. Okay, next, what else do I need? Okay, I need to ask. What do I need to ask? How am I going to know that the letter that this student got is an A or a B or a C or a D or an F? If, okay, I'm going to ask if what? If grade equals 100? It's greater than 90 or equal to. If it's greater than or equal to 90, what do I do? Okay. Yes, you do. Yes, I understand your question. And it's a good point. It's a good point. But remember that the computer is going to be doing this in order. First one in is going to do that one. If we put 80, ask first for the 80 and then for the 90, then it will be mixed up. But if we do it in order, it's going to give us the correct. So if it's greater than or equal to 90, I need to display what? I need to display the whole thing, right? It's name. You have a name for this class. Display. I'm just going to put it once. Ta 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 ta. You have an A for this class. Okay, that will be if it's a 90 or above. Then, what about if they give you a 70 or an 85 or a 40? Okay, I'm not coding yet. I have to ask again, right? If what? If grade greater than or equal to 80, display the same thing, right? But it's going to be a B for this class. Okay, that's it. This is the end of the program. Okay, if grade is greater than or equal to 70, display ta ta ta, you have a C. And display, and then everything here, D. That's it. Less than 59. Or equal to, okay, display an F. That's it. And okay, I'm going to check my pseudocode before I start my code, right? I have to check that every one of this is correct. So we start with IOStream and string. I call variables name, that is going to be string. It will work because I already have my preprocessor directive. Grade, that is an integer. And letter grade, that is a character. Then I'm going to be asking for the name. Perfect, it works. I already have a variable for name. Ask for the final grade. Perfect, I have a grade variable for it. That is an integer. Okay? And then I'm going to be checking if the variable that I just fill in, which is grade, is greater than or equal to a 90. Let's suppose that it's an 85 this time. This is true? No. So we go to the next one. Is the grade greater than or equal to an 80? Yes. We display a B. Perfect. And we continue down. We have to continue down. If grade is greater than a 70, I display a C because it's an 85. If grade is greater than a 60, I display a D because it's an 85. So the grade is less than or equal to 59? No. So I'm going to be displaying B, you got a B. You got a C, you got a D. So this is not going to work. It looks correct, but it's not going to work. I already tested it as if I was the computer. You're giving me the instructions. So what do we need to do, Chris, to correct it? Use an AND for the first four, which are? Okay, how do I put an AND here? This is not code. How are you? Say it to me. Say the question. If grade is okay, I want to say it's between this range, right? Between the 90 and the 100. If they get a 90 and 100, we want to give them an A. So to say that, I'm going to say if grade is greater than or equal to a 90 and grade is less than or equal to 100. If it's within that range. If grade is greater than a 90, but equal to or less than 100. That's what I'm saying there. Then I'm going to give an A. And I'm going to do the same thing for the other one. If grade is greater than or equal to an 80 and grade is less than or equal to an 89, right? Yes. Yes, we did it with the 85. If I put 101, it will give me, you got an A, you got a B, you got a C, because the 101 is greater than the 90, is greater than the 80, is greater than the 70, is greater than the 60. The last one is not going to give us a problem because we're asking for less than. So it's going to be false. So here again, I'm asking if grade is greater than or equal to an 89 and, okay, remember both of them need to be true, and grade is less than or equal to an 89. We're going to display that. And we're going to do the same thing here. And grade is less than or equal to a 79. And grade is less than or equal to a 69. They got a D. Okay, I'm going to go into that as well. We can add it here. If grade is less than or equal to 59 and grade is greater than or equal to a 0, then we display that. And we have made every single block, right? Okay, I'm going to test it again. Let's suppose that the user enters at 105. They make a mistake, right? So I'm the user, I type my name, and then I put 105, and then the program starts. And we have, is grade greater than 90 and less than 100? No. So we go to the next line, which is number 5. Number 6. Is between 80 and 89? No. So we jump to the other line. Is between 70 and 79? No. So we jump to the other line. 60 and 69? No. So I jump to the other line. 59 and 0? No. So I jump to the other line and the program closes. And I'm the user, so I'm going to be there wondering, what happened? What did I do wrong? Why did the program close? Okay, what I need is, you're correct, ask the user, give me a correct number, right? So I need to let the user know you're wrong. The input that you gave me is incorrect. Try again. Right now, we don't know how to go back, right, and start all over again. We're going to do it in the next chapter. But what we can do is at least let the user know, hey, if none of the ifs are true, then send a message letting the user know that there is an error and start the process again. None of the ifs are true. Remember our trailing else? If this is true, do it. But it's not, else if, else if, else if, else if. And then at the last, we have just an else. The last else without an if. So if this is not true, the first one, it's not between the 90 and 100, go to the next if. If this is not true, go to the next if. If this is not true, go to the next if. If this is not true, go to the next if. If this is not true, go to the next else now. And we're going to display a message letting the user know that there was a mistake. The program is about to close and you have to start again. But at least we're giving them something. We don't want just to let the user in front of the computer just wondering what happened. He or she may never know that they type a 101. So this is when the trailing else comes handy. Okay, start coding it. We still have like 7 more minutes.